Hello viewers, in today's session we are going to discuss two important problems from beta and gamma functions, and here we are going to evaluate these two important integrals with the help of some results from beta and gamma functions. So let us start and let us first take this problem. So here we can take this integral as I, right? Now here what we will do, we'll write this integral as 0 to infinity, and here in the denominator we have x raised to half. So taking this x raised to half to the numerator, we can write x raised to minus half, and then here we have 1 plus x raised to 1, right? So the first step is to write this integral in this form, because we wish to convert, or we wish to write this integral as the definition of beta function, that is beta m comma n is given by this integral 0 to infinity x raised to m minus 1 over 1 plus x raised to m plus n, where m and n are greater than 0, right? So here we have dx, and this integral can now be written in this form by taking m minus 1 is equal to minus half, and m plus n is equal to 1, right? So let us now solve these two equations to get the values of m and n. So from here we have m is equal to 1 minus half, that is equal to 2 minus 1 over 2, that is half. And taking m is equal to half in this equation, we have half plus n is equal to 1. So n is 1 minus half, that is 2 minus 1 over 2, that is half, right? So now this integral I can now be written as 0 to infinity, and x raised to minus half can be written as m minus 1, and m is half, so we have half minus 1, and here we have 1 plus x raised to 1. Now 1 can be written as m plus n, right? So m is half and n is also half, so we have half plus half, right? So now this integral is of this form, so we can now write this as beta half comma half, and obviously half and half are greater than 0. Now here we'll make use of an important result connecting the beta function with gamma function, that is beta m comma n is given by gamma m gamma n divided by gamma m plus n. So here we can now write gamma half, then we have gamma half, and then we have gamma half plus half, right? Now gamma half is equal to square root of pi, so we have now here square root of pi, here also we have square root of pi, and in the denominator we have gamma 1, and gamma 1 is equal to 1, right? So root pi times root pi is simply pi, and gamma 1 is 1, so we have pi, right? So the value of this integral is equal to pi. Now let us take the second problem. So now let us take this integral as I, right? Now here the limits of integration are from minus infinity to infinity, and here the integrand, that is say f of x is x square over 1 plus x raised to 4. Now if we replace x by minus x, then we have f of minus x is minus x square over 1 plus minus x raised to 4. Now since 2 and 4 are even numbers, so here minus x square is simply positive x square, and here the fourth power of minus x is simply x raised to 4. So this function is equal to f of x. So we arrive at this conclusion that f of minus x is equal to f of x, which suggests that our integrand, that is f of x, is an even function, right? And here we can now make use of an important property of definite integrals, which says that the integral from minus a to positive a, and f of x dx is equal to 2 times the integral from 0 to a f of x dx, provided this integrand, that is f of x, is an even function, right? And in case of odd function, this integral is equal to a 0, right? So here we have just proved that f of x, that is x square over 1 plus x raised to 4, is an even function. So now this integral I can be written like this, that is 2 times the limits from 0 to infinity, and f of x is x square over 1 plus x raised to 4 and dx. Now we have to convert this integral into the beta function, that is into this form. So to convert this integral into this form, we have to make use of the substitution method. And for applying substitution method, we'll take x raised to 4 is equal to some variable, say t, right? So x is now equal to t raised to 1 by 4. Now let us differentiate x with respect to t. So dx over dt is equal to d by dt of t raised to 1 over 4, that is 1 over 4 t raised to 1 by 4 minus 1, applying the power rule, that is the derivative of t raised to n with respect to t is nt n minus 1. So here we have 1 over 4 t raised to minus 3 by 4. So now we can write dx is equal to 1 by 4 t raised to minus 3 by 4 dt, right? Okay, now let us change the limits accordingly. So here x varies from 0 to infinity. So when x is 0, then the value of t can be obtained from this expression. So t is 0 raised to 4, that is simply 0. And when x tends to infinity, which is our upper limit, so t also tends to infinity. So the limits remains the same. So now this integral can be written as 2 times 0 to infinity, and for x square we can now write x is equal to t raised to 1 by 4. So we have t raised to 1 by 4, and then we have the square and 1 plus t, and for dx we can write 1 over 4 t raised to minus 3 by 4 and dt. So now let us rearrange the terms. So here this 2 it get this 4 get cancelled with this 2. So we have half outside the integral, and then we have 0 to infinity, and here we have t raised to 2 by 4, and then we have 1 plus t, and here we have t raised to minus 3 by 4 and dt. So now we can write I is equal to half and 0 to infinity, and here the base are same. We can add the exponents. So we have t raised to 2 by 4 plus minus 3 by 4. So this is 2 minus 3 by 4, that is t raised to minus 1 over 4. So here we have t raised to minus 1 over 4 and 1 plus t raised to 1. So here we can take 1, and here we have dt. So now if we compare this integral with this one, then m minus 1 can be taken as minus 1 over 4, and m plus n can be taken as 1. So from here m can be obtained 1 minus 1 over 4. So this is 4 minus 1 over 4, that is 3 over 4. Now from here we have 3 over 4 plus n is equal to 1. So n is 1 minus 3 by 4, that is 4 minus 3 over 4, that is 1 over 4. So now we can write I is equal to half 0 to infinity t raised to minus 1 over 4 can be written as m minus 1. M is 3 by 4, so we can now write t raised to 3 by 4 minus 1 and 1 plus t raised to 1. 1 is m plus n. So m is 3 by 4 and n is 1 over 4, and here we have dt. So now we have half, and this integral is given by the beta function. So beta m comma n, we have 3 by 4 and 1 over 4. So now to evaluate this expression, that is this beta function, will again use this result. So we have half gamma 3 by 4 gamma 1 over 4 divided by gamma m plus n, that is 3 by 4 plus 1 over 4. So we have half, then gamma 3 by 4. Now 3 by 4 can be written as 1 minus 1 over 4, and here we have gamma 1 over 4. We have written 3 by 4 as 1 minus 1 over 4 because here we are going to use the famous Euler's reflection formula. So here we have 3 plus 1, 4 over 4 is 1, that is gamma 1, and gamma 1 is equal to 1. So here we have 1. So we have half gamma 1 minus 1 over 4, gamma 1 over 4, and now the Euler's reflection formula says that gamma 1 minus n times gamma n is given by pi over sine n pi, right? So now if we take n is equal to 1 over 4 in this formula, then we have gamma 1 minus 1 over 4, gamma 1 over 4, that is pi over sine pi by 4. N is 1 over 4. So gamma 1 minus 1 over 4 times gamma 1 over 4, this expression is equal to pi divided by sine pi by 4. So here we can now write half and pi over sine pi over 4. So now we have pi over 2, and then we have sine 45 degrees is 1 over square root of 2. Now taking square root of 2 to the numerator, we have pi root 2 over 2, right? So now we can also write this expression as multiplying the numerator and denominator by root 2. So the value of I is now equal to pi times root 2 times root 2 is 2, and here we have 2 and here we have root 2. So 2 and 2 get cancelled, so we are left with pi over square root of 2. So viewers, the value of this integral is equal to pi over square root of 2. So this is how, by the application of beta and gamma functions, we can easily evaluate these kind of integrals.